All right, let's take a look at a dilution problem. So let's define this problem, right? That's one of the keys to these type of problems. And so here we have a molarity. So, and we're being asked how many milliliters. Now remember, with this M1V1 equals M2V2, one of the nice things is we can convert everything to liters, but if your volume, if one volume's in milliliters and you're solving for milliliters in the other one, you do not have to change those units. And that's what it looks like we have here. So we have how many milliliters of a 0.3 molar NaF would be required to make a 0.04 molar solution when diluted to 250 milliliters of water. So one of the trickiest parts of this is figuring out what's M1, what's V1, what's M2, what's V2. So I'm going to take the larger molarity as my M1. So I'm going to say 0.033 molar, but I don't know what my V1 is. And it's okay to, any of these can be the missing variable. It could be M1, V1, could be M2, it could be V2. Doesn't really matter. So it's just set it up how it makes sense to you. My M2 for me is this 0.0400 molar, and my volume 2 is 250 milliliters. So essentially, how much of this more concentrated solution do I need to take to have it be 250 milliliters? So I would dilute it. So how much of this concentrated stuff will I pull out and then dilute the rest with water? So let's take a look, right? So I have this 0.3 molar solution, so it's got a lot of moles in it. I have as much as I need, but how much am I going to, right, extract out and put in this other beaker? And then I will end up diluting it to 250 milliliters. So I need to put a certain amount, is because what I'm trying to do is capture a certain amount of moles, put those in, and then dilute it so that I have the concentration that I want. So let's rearrange this. So I'm going to solve for V1 by putting 0.040 molar times 250 milliliters divided by 0.3 molar. Those molars will cancel and we'll be left with milliliters, which is what we want. So 0.04 times 250 divided by 0.3, I get 33.3 milliliters need to be extracted of the high concentration, put in this other beaker, and then I'm going to fill the rest up with just water. And again, we got another ionic one here, Na plus, F minus. So when it's in solution, it likely will, or it will be in its ion form and not as its lattice structure. Okay, so let's put in our 33.3. Now this might be different for you because that number is grayed out. And there we go.